Hello, in this video I'm going to demonstrate how to create a footprint from a data sheet or any data from a PDF. So starting here with a blank footprint with our footprint editor, we'll go to Tools and then select the Import Data from PDF option. At that point we will be presented with the PDF scraper, and the first step we'll do is select the PDF. For this one, we'll use this PDF, and then you can scroll through the pages with arrows, or just enter the direct page number. For this example, I know I want page number 8. Then you can zoom in and out, and when you click and drag, you can make your selection on the PDF that you want to scrape to the editor. So once that selection has been made, you can select the Scrape Selected Area option, and it's going to be brought into the editor as seen here. Now the first thing we want to do is clean up some of these extra lines that aren't needed. So we'll just go through that real quick. And once everything is cleared up, then we have the view of the basic footprint of the part. Now something else you might want to note is that since this was scraped from the PDF, we might want to select all of the lines and mirror them so that they actually represent what the part would be like once flipped over onto the footprint. Now that that's done, we might want to shift the origin. As you see, it's placed into the editor in relation to where its position on the sheet was. So if its origin is not marked in the footprint when scraped, what we can do is ensure that our snap function is on, and just simply draw a line from corner to corner on each side. Where they intersect will mark the origin here. So next we can go to the Place Special Point options and select the origin. And now when we click the intersection of the lines, it has shifted the origin to there. So at this point we can delete those lines now that we've got that moved. We also might go to the Special Point and shift the Pick and Place point as well, which we can now just click the origin. So now that our lines have been mirrored and shifted, we might also want to scale them. To do this, we'll want to once again verify that our snap is checked, and then go to the Tools menu and select the Scale by Measure. From here we'll want to measure the distance between 2 points that we know a measurement for. So say this, the narrow side of the body. It says when we measure between, it says they're roughly 64 mils, but say we know that they should measure 5 millimeters. So once we place that in, you can see now it's scaled all the lines that was brought in. So now that we have shifted and scaled the lines from the data sheet, the next step would be to make some pads. So if we select the lines that we've brought in, and under the Lines menu, when you right click, there's a Make Pads option. When selected, it takes a look at all the selected lines, and any that form a basic polygon, it places a pad roughly the same size as the polygon that's formed. And one thing to note is that the default pad shape is a bullet shaped pad, and the curved end of the pad indicates the toe of the pad, so we want to make sure that all of those are facing outward from the center of the part. So these on the top row are good, but some of the others need to be fixed. So we can select the pad and rotate, or as a shortcut just press the R on the keyboard. And once all the pads are rotated, the next step would be to number them, because you can see by default they come in as a pad number 0. we will go to the Edit menu and select the Renumber Pins function, at which point you'll be prompted to input a starting pin number, which for us will be 1, and we'll select OK. And we'll also verify in our selection mask that pins are enabled to be block selected here. And we'll also go ahead and turn off our snap so that it's a little easier to grab these pins. At which point, when you drag to select the pins, it'll number them in order from the start of your drag to the end of your drag. So we went from top to bottom. Here we're going to go from left to right. Then we'll go from bottom to top. And then from right to left. And you'll see it's numbered the pins accordingly. Now we'll right click to end that command. And the next step that we'll need to do is add a toe, heel, and side to these pads. To do that, we'll just select a pad style, and under the pad style menu, we'll select Add Toe, Heel, Side. And from there, we'll be presented with a menu that displays the name of the current pad style and its width and height. And from there, we can either add the toe, heel, side according to IPC standards or for user-defined standards. For using the IPC, we know that this footprint is a quad flat pack, so we'll select the quad flat no lead or QFN, and then you can select the minimum, maximum, or nominal. For this example, we'll just leave it on the nominal. And then we also have the option to change the pad shape, or if you uncheck the box, it'll leave it the default bullet shape. So we'll go ahead and change it to a rectangle, and when we select OK, you see it's applied those changes to our pad. Now we'll just do the same for the other pad style that's been found. Once again, selecting the QFN option, and you also have the option to change the between minimum, nominal, and maximum, as well as the pad shape as well. And now we've added the toe, heel, side to all the pads. From this point, we might want to add some detail on the body and more of the land pattern. So we can, if we use our selection mask here, we'll just have lines available inside or touching, and we can grab the outline formed by these 4 lines of the body, and we can go to properties and go ahead and transfer them from the ghost layer that it brings all the lines from the data sheet to the top assembly. And we select OK. Now you can see we have the outline on the top assembly layer. Next, we may want the Silkscreen, so we can select those same lines that form the outline of the body, and if we right click under the lines menu, there's a copy to new layer. This allows us to take the lines and copy them to a new layer, and also apply an offset size and a new line width for the new lines created. So we'll go ahead and copy these to the top Silkscreen layer and expand them by an offset size of 5 mils, and also increase the line width to 5 mils. And you can see it's also trimmed the Silkscreen where it doesn't interfere with the pad according to the user settings. Next, we might want to place bound. To do this, we'll need a polygon that has the same size as the body outline. So we can once again select these 4 lines that outline the body of the part, and under the lines menu we can make polygon. From here we can select the polygon that's made, and under the polygon menu select the enlarge polygon option, at which point it allows us to create a place bound with an excess size of either the according to the IPC least, nominal, maximum, or a user-defined size. We can also uncheck this box to leave it on the current layer. We'll go ahead and move it to the place bound layer, and then we can also create lines and route the place bound around the pads. So we'll click OK for those default options, and you can see now it's created a place bound polygon and as well as perimeter lines. The polygon that we used to start with on the top assembly layer, we can now simply delete that. Next, we may want some polygons on the contact layer. To do this, we'll ensure that any lines inside our block select will be picked up, and you can simply go through the lines that create the outline of the pen and right click under the lines menu, select the make polygon option, and you can go through for all of the lines that outline the pen, and from there you can select the polygon and change the layer to the contact area layer, and you can do that for all of the lines that form the outline of the pens. After that, there's not a whole lot left, but we may want some attributes placed. So under the special point option, we have an option to place user XLR data. This, when selected, that brings up a menu that's user customizable to map these buttons to specific XLRs that contain data. For this demo, I have this button mapped to just some default attributes. So once selected, we're prompted to tell where do we want to place the data from this XLR. We can either place it at the origin or a user-defined point. For this, we'll just place the attributes at the origin. And you can see it's brought in that data from the XLR and placed it right at the origin. Next, we may want some dimensions. For this, you want to ensure that your snap option under the grid menu is enabled, and this button here, the dimension button, needs to be selected. And from here, you can click and drag between points, and if that snap option is enabled, it will automatically snap to corners of pads, center of pads, the start or end points of lines, points on a polygon, and also the grid points and intersections of lines. So like I said, you'll just click to start the dimension, drag to a snap point, and when you release, you can drag and then click again to place the dimension. So you'll see the body has a width of 5 millimeters, which matches what we scaled it to initially. And you can use this to dimension pads, pitch, the pitch between pads, and also it'll do vertical and horizontal dimensions as well as just the true distance between 2 points. So if we, I'll zoom out a little bit here, and if we select between the corners of the body, if we drag to the left or right or horizontally, it'll give us the vertical measurement, or if we drag up or down or vertically, it'll give us the horizontal measurement, or if you drag perpendicular to the 2 points, it'll give you the true distance between the 2 points selected, giving you a wide range of options for dimensioning the part. And I believe the last thing that we would need is under the footprint option, the rename button will allow you to actually name the footprint. And with that, we have created a footprint in a matter of minutes just from the data sheet itself. Thanks.